Hi, I'm Mark Russinovich. I'm Chief Technology Officer of Microsoft Azure. I'm also a Technical Fellow and Deputy Chief Information Security Officer for Azure.
And I'm Scott Hanselman. I'm the Vice President of Developer Community here at Microsoft.
And what Scott and I are going to talk about this morning is about vibe coding, specifically how powerful vibe coding or AI-assisted coding can make software developers. But at the same time, software developers need to understand its limitations today, limitations that are likely to be there for the foreseeable future, if not forever. And we'll also discuss the implications of that when it comes to hiring early in career developers and what we should do to train the next generation.
We've had a lot of feelings lately about the art and the discipline and the pitfalls of vibe coding. We've got that on our slides right here.
I mean, I think a lot of people get this, hey, vibe coding is just about programming, or I can take a boot camp and learn how to vibe code and know a little bit of programming, and I'm ready to go off to vibe code a whole production system.
Now, how do we make sure that we are just you and I, not a couple of effectively old people who are resisting this stuff? Because AI-assisted coding has been around of a sort for 30 plus years. We might want to talk about that. Are we just a bunch of oldies and we're resisting the future?
We all, you always run the risk of being blind to your own biases, but I try to get as many outside views as possible to inform what I believe. And I feel pretty confident at this point, having talked about this with so many people. But you're right that AI-assisted coding has been around a long time. And in fact, people just say, well, it's just like compilers. We didn't, people did assembly language and machine language, and AI is like the equivalent of the modern compiler. And if you take a look at some of the assistants that have developed over time, IntelliSense in 1996, as far back as then, doing autocompletes on methods and struct variables, to IntelliCode, which would fill in a class with stubs that you could then go start to populate in the most natural kind of introductory lines like that you see, and that was with AI models. And then OpenAI Codex, custom trained coding model, GitHub Copilot multi-line completions, again, custom trained large language models started to show up in 2021 to aid with coding, and ChatGPT in 2022. I'm sure just about everybody that's watching this at some point after ChatGPT showed up was asking ChatGPT to write functions or taking code from their code bases and pasting it into ChatGPT and asking for enhancements and then pasting it back. Then Cursor made it so you didn't have to do that. So it built it right in. So to GitHub Copilot Chat, so you could chat and then generate those code snippets and then insert it right into the editor. But the big breakthrough that's really got people really now wondering about, hey, is vibe coding the future? You do need software developers anymore? Was the agents that started to show up with Cursor agents, GitHub Copilot agent, Claude Code, Gemini CLI, and the list goes on, where now it can go and autonomously go and work on code, doing the builds, doing the tests, writing the functions, creating files. And now I've seen personally, and I think you have too, since the beginning of the year, my productivity has gone up from maybe a slight boost of 1.5-ish to 2.0 in my coding projects to now 5 to 10x. And this is what I hear from a lot of people.
Absolutely. And I think that that's a point that we want to just hit really hard for a moment, is this idea that there is unquestionably, regardless of the efficacy of the AIs, for senior engineers, for engineers that have been around a while, that have a good sense of code smell, a good understanding of the structure of the system, there's unquestionably a boost, a significant boost. It might be not 20%, it might be 2x. You have gotten more done, frankly, especially hobby projects you didn't really have time for, small to medium-sized projects, than you've gotten done ever before.
Yeah, I just would not have the time to even consider doing some of the projects that I've done now and not just done, but done in a short period of time in my spare time. And I think you can see this in our GitHub kind of stats.
Yeah, take a look at our GitHub stats. Our own AI-assisted boosts have been significant. We've been doing more commits in more repositories, things that we kind of would have taken 3 days or being done in an hour. Projects that we wouldn't attack because we thought they were maybe tedious or a little bit boring, but they were useful utilities that we wanted to get out into the world. We're just doing them. Stuff you probably wouldn't spend your valuable time on, I would think.
You're right. And one of them that is my favorite example of this is I play Wordle every morning, and the Wordle stats in the New York Times make it hard to see your trends over time or to go back and look at individual history. They've got a pretty clunky interface. And so I thought maybe I could generate a Chrome extension that would go and scrape that data out of New York Times and then show it in a very rich way for me. I don't know React. I don't know CSS. I know some HTML. I don't know Chrome browser architecture or how to write an extension. And yet in literally 2 weeks of part-time work, I developed, it's in the Chrome extension store, you can go find it, a WordleBot stat analyzer, a Wordle stat analyzer. You can see here just a screenshot of it, and then you can see the repo there. You can go get it directly from there if you want to, or make contributions. This thing I wouldn't even have considered before. And now I've got my own really cool stat analyzer.
It's really significant that you say that you wouldn't have even considered it before. I'm finding myself in the same situation. I recently was abusing GitHub Actions. I was using way more Actions storage than I was appropriate for a free account, and I got an error. So I said, I'm going to go look for the GitHub Actions dashboard, and found that one didn't exist. I don't know TypeScript very well. I have never really published any NPM packages, but I was like, the world needs a GitHub Artifacts Analyzer, and I vibed it in about 4 hours and published it. And now it's out there. And then other people have built on top of that with really good looking dashboards and graphics. And it's an example of, I had an idea, and the only thing that was keeping me there was the friction between the idea and the actual doing it. And the AI in this case gave me a boost, reducing that friction.
And Microsoft Teams as well have also seen this kind of boost. Like here's an example, Office Agent, which is right now is in a preview. It'll be public in the near future, is a agent system that lets you create content using Office tools. Like you can say, go create a PowerPoint that has this, and it'll go do research for you and then build the slides and ask you some questions about it and create diagrams, or go create this Word document. This is very polished. I've been playing with it. 7 engineers over 10 weeks from idea, prototype, to having it released in a consumer preview, with 98% of it being AI generated. Huge code base too, and it's really polished.
Okay, but we were saying at the beginning of the conversation that we're seeing a boost. Were these all senior engineers? Were they a mixed group of engineers? And are we, because right now this is the hype part of the presentation where we're like, look what you can get done. Just a few engineers in just a few days can do this kind of work.
Well, the problem is that these agents are very much like interns. And I know that you've run into these kinds of problems where it's like they seem brilliant 1 minute where they're telling you about algorithms or writing code that is really tight, to the next minute just making ridiculous claims or mistakes that even a junior programmer would likely not make.
The Aspire team at Microsoft, one of the things that's interesting to note here is that that number 322 on the top committers, that's actually David Fowler, distinguished engineer David Fowler. Notice that there's more commits from the bot than there are from David. That's not to indicate the bot is a distinguished engineer or better than David, but what it's showing is a fundamental change in the structure of how David and his team think about who should be doing the work. It's, of course, a metric that can be gamed. The number of commits isn't necessarily valid. But what's happening is David and the other senior engineers are having conversations in the GitHub issues, and they are directing the bot themselves. So it's almost a virtual version of sitting in front of a whiteboard. They're having a lot more fun, too.
It's a little misleading. So what GitHub Copilot initially created those PRs, but then humans interact with the AI, the agent in the PRs, correcting it, enhancing it before it's finally committed. So you could actually say that if you took a look at who's commenting on this PRs to guide the agent, that it's those humans that were working with the AI to create those PRs.
Exactly. And the thing that's worth noting is that the boost that we're getting from AI is not just from the number of commits, but the learning. I felt like I learned a ton when I was doing it. You learned about React. You learned about how browser agents work. These engineers, these senior engineers that work on Aspire, learned a ton while they were interacting with these agents. But it's worth noting that the agent didn't really learn anything.
Yeah. Well, I mean, this is the thing. You tell the agent one thing once, and it might honor that instruction, and then the next day completely forgets. So they are interns in the sense that they make these mistakes. But they're interns that don't remember very well. And so they'll make the same mistakes over and over again.
Which brings us to our meme that vibe coding is the future.
Yeah, now pause here for a second to let everybody look at this and spot the issue with this presumably vibe-coded authorization dialogue.
Seems very intuitive, and I can totally see why they would think that was a problem.
And if you're not looking closely, you're not even going to notice this, right?
Yeah.
You assume, oh, account verification dialogue, standard stuff. Any AI agent should be able to get this right.
This kind of stuff is an example where I like thinking about what is the essence of coding, and it's about specificity, about clarity, about understanding the system. And I personally just don't think that these systems in large scale can understand the context. I would say that even large context windows LLMs don't have as large a context window as you or I do.
Exactly. I mean, the thing is, what we've got are hyperly sparse attention over our entire context, which is our memory. So we can keep in our heads hundreds of things, and they pop to the surface at the appropriate times, when an AI system doesn't have that kind of scale in its attention, and I don't think ever will have the true scale of a human brain.
That's a great point. I actually haven't thought about it that way, that there are little moments in my history, in my experience, where something will go, oh, I remember we did this back in 85, da, 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 da. Or, oh, I read a paper about that 2 weeks ago. That's the context window kind of paging in and out of my short-term memory.
Yeah, or thinking, oh, you know what? I need to pay attention to which version of the API I'm using here. I should be using the non-deprecated OpenAI API here instead of the one that's deprecated. The LLMs aren't really sure what's deprecated, what's not deprecated, and might give you the wrong APIs, the wrong packages, the wrong framework, the old version, the broken version, mix the new version and the old version.
And in doing that, they, I think, have a challenge understanding what done is. Like for us, there's a real clear understanding about when we are done. Sometimes they'll think that they're done and then just declare victory.
So I run into this all the time where and I'm sure other people have too. It's, hey, this is production ready. I hear that one a lot. The AI likes to say that. Certain models like to say that a lot. It's production ready. But if you look, there's like this one, incredible breakthrough. But by the way, there's an error, this gigantic error. So I personally would consider a breakthrough where you have some debug insight, but then there's huge problems that you've discovered in the process. And this kind of thing happens all the time.
Yeah, I've had them kind of gas me up and talk about how great I am and what an incredible breakthrough that I've created, or what an amazing new thing that I've done, when we're just putting together a pretty straightforward back-end system. Yeah. And then blame is another problem, where they will declare that it's not their fault or our fault. In this case here, it's saying that the benchmark is too good. Yeah. The system is too efficient.
For the benchmark. Yeah, the benchmark's crashing. This is like blaming the compiler, which it's very rare that the compiler has a problem, but it's common for humans to go, there's no way it can be my code. It's got to be the compiler. This is the LLM example here. That's running this transport performance benchmark. The benchmark crashes, and immediately the LLM concludes that, hey, it's the benchmark that's broken, not my code.
These things tend to get distracted. I know that we don't want to anthropomorphize them. We don't want to pretend that they're humans, but they do behave like humans. And when we say that they are enthusiastic interns, we're not certainly trying to degrade or denigrate our interns that are certainly, better. I think they're interns on day one, fresh out of school. Yeah. With bright eyes, and they know everything, except every single day is day one for these interns. While our interns, even after a week.
Yeah, intern. Yeah.
Yeah, exactly. Sometimes they will completely get distracted. And in this case here, you had one not only get distracted, but declare to you that it got distracted in an apology.
Some really kind of laugh out loud moments during AI assisted coding. In this case, for the WordleBot code, it was generating synthetic data for testing. I told it to switch over to real data, and then I found out that it started to do that and then switched back to synthetic data instead of using real data. I had to correct it another 2 times, and then ran into this where I'm like, it's still not using the real data. It still looks like it's generating data. And I tell it, you shouldn't be generating any more data. You should be using the real data now. And then it says, you're right. I got distracted by trying to simulate data when I should have been extracting the actual game data. So just going back to, you can tell it one day one thing, and then it forgets, slides back into old behaviors. I experienced this firsthand in this project.
Now, are we cherry picking and picking on a particular model? Are we just showing and giving a list here of all the things that one model does poorly, or is this a mix of models?
Yeah, it's total mix. So when I do work with AI coding, because I want to understand the strengths and limitations of each one, I also, a lot of times when one gets stuck, I'll give the problem to another one. So I'm using GitHub Copilot Agent, Claude Code, OpenAI Codex, Cursor, Gemini Code. I try them all. And so this is, and by the way, cherry picking problems, I've got dozens and dozens of examples like this from all of them. It's not like one is free of these kinds of problems that the other ones have.
Some of them are pretty extraordinary, where it literally thinks it's done and will put a placeholder and just be effectively lazy. And it seems to me like a context window problem, whether it was I got distracted or I didn't finish this. Without a plan, I have found that these don't do well. Trying to one-shot stuff without a plan is a problem. In some of these cases, even though the plan, I think, is a good way to get around it, it'll move the problem from the plan to somewhere else. So, for example, you might say fix something, it'll check it off in the plan, but then here we've got effectively a to-do that's been buried in our code. And if we never took the moment to look at our code, we would never see this. It would actually hide this.
This is not a to-do.
Yeah.
This is a fix.
It hasn't marked it. It's calling it a fix, and it's doing a very junior engineer thing to do. It's trying to solve the problem by any means necessary. And in this case, asleep is completely inappropriate because it doesn't understand asynchrony and multi-threaded code.
And so, this might hide the problem, but it doesn't really fix the problem. And by the way, there's a paper that just literally came out a few days ago from some researchers that looked at AI. They took common coding benchmarks and they changed the tests to actually counter what the instructions were, like generate a prime number checker. And then they got in the test a failure case for a prime number, which should pass. And what they found is that AI systems go and just try to make the test work instead of actually making sure that what they're doing is actually following the instructions. So, and they're very much optimized towards, let's just get it working no matter what way it takes. Hard coding things, putting in special cases just to make the test pass, even though the test is clearly incorrect.
That brings up a really interesting philosophical question, because I think it's important for anyone using AI-assisted coding to understand where the data came from, the corpus of data. It is very common in the middle of the bell curve to have sleeps. It's not a best practice, though. And I think if you assume that an AI is trained on a corpus which is best practices, you are going to assume that the AI will generate best practices. But this is a reality. People putting sleeps in there and calling it a hack or a fix or a whatever, that combined with reinforcement learning and the reason that AIs are trying to please you, they're trying to please you. I want you to be my friend. You're absolutely right, Mark Russinovich. I'll do the best I can to serve you. Rather than push back and rather than be good, it does a hack like that. And often that leads to really flawed reasoning.
Yeah, in this case, I was trying to get it to understand how to make this race condition go away, actually to surface it so it could actually debug it. So me with the AI could figure out what was causing this race condition. And it was putting the sleep that you just saw on the wrong side of the client server interaction. The sleep that it was putting in didn't make any sense. It should have gone in the server side. So I pointed that out, and then it admitted it made an error and said, hey, this means my hypothesis about client not ready for server responses is correct.
Well, because everything you say is correct, right, Mark? You're absolutely right.
Yeah. In fact, I was going to name myself absolutely right, given the number of times that it's called me absolutely right.
It's constant. The sycophancy is a huge problem. Additionally, completely hallucinating or fabricating solutions as well is extremely challenging when dealing with this kind of work.
Yeah, you have to watch to see what it says is true. In this case, it claims that everything passed, all the tests passed, and then you can go look very clearly in its output that it was referring to itself when it made that conclusion that there were some failures.
So this series of slides might seem negative, but what we're really trying to call out is that early in career AI drag, where if you don't have the sense of smell, you're not going to be able to catch it when it makes these kinds of mistakes.
Yeah, and you're going to get the senior boost if you do. And what this means is that you're going to have an incentive to just hire senior developers, because the junior developers are actually going to get slowed down. The senior developers get the boost. Why even hire junior developers?
Well, you and I both really like Ethan Mollick and how he thinks about this concept of working with a wizard. Why is it bad to give work to a wizard?
Yeah, well, when you talk about how do you become proficient in AI, in software engineering, to become somebody that can work with AI and get that boost, you need to learn the basics so that you can spot these errors and correct the AI and redirect it and call the BS on it. What Ethan points out is that we're in this era of wizards. This is what people call vibe coding, where you just write it and you have no idea what's going on underneath the hood, what the architecture is, what went into the design decisions. It looks like it runs, so I'm going to accept it. Or it looks like a good answer, so I'm just going to accept it. And what he's pointing out here is that means that you're not going to learn anything.
And that is going to be a problem. We propose that, and I think others have proven it with data, that your brain kind of rots a little bit. I think it's different though, because in the 90s we used to say, oh, IntelliSense is going to rot your brain. It removed toil, but I think it didn't remove so much toil that it left you basically alone and doing no work at all. Some of these things, AI will remove so much work that there's nothing left for you to do. And if you don't understand the system, you're going to eventually get nailed.
Yeah, if you don't have critical thinking, if you're not using reasoning, that's a muscle, and you have to learn, especially a muscle or critical thinking and reasoning in the context of a domain like software engineering. This study, by the way, is just an amazing one to prove to anybody you need to actually use your brain to learn. They took 60 adults between ages 18 and 40 something in the Boston area, had them write SAT style essays, broke them into 3 groups. One group closed book, one group used Google, one group got to use ChatGPT. They measured their brain activity while they were writing, and then they asked them questions about what they'd written an hour after and a week later. And the results are exactly what you would expect. The people that use ChatGPT literally could not remember what they wrote an hour later, and their brain activity was very low. The people that had closed book could remember not just an hour later, but a week later what they'd written, and saw a lot of higher level brain activity while they were writing. So there's no shortcut for learning. You got to do it the hard way.
I like that. There's no shortcut for learning. And in the future, right now we live in a world of tech leads talking to early career developers. I would propose that tech leads will work with early and career developers that will have their own interns, their own AI assistants. So everyone's going to become a manager. It's going to become even more important than before for us all to understand what it is we're building and catch tech debt before it ends up getting in production.
Yeah, and this is something that you and I have concluded, which is software engineering needs to move to an apprenticeship model, because there is no incentive to hire a junior engineer to do the work that AI intern can do. So how do you replenish the talent pipeline? How do you get those senior engineers once the ones you've got retire or move on? And so we believe you need to actually hire specifically to replenish your senior engineers with an apprenticeship model that puts the early in career developers in a position where they're actually going to learn the hard way, rather than just completely rely on AI and not really understand what they're doing. And so this is what we call the preceptor model.
I've been pushing my team to get back to the command line, learn how to drive stick shift, because these AIs are going to solve the problem using get, using sed, using awk. They're going to be using the tools that I take for granted that a lot of young people are not learning at all. And that's just going to look like magic. And the next thing you know, they're working with wizards, and we don't want to do that. The other thing we want people to be thinking about is formal planning, formal analysis. You want people to be thinking and planning. So we're spending more time trying not to one-shot. We're trying to recognize this is going to be a multi-shot, complicated experience. So we're breaking things down as senior engineers into a small task at a time with a context window that the AI agent can handle. And then we're building systems around it. That's the software engineering part, where we're going to build and run tests after every step. And we need the AI agent to know that those builds and those tests matter. And if a test fails, stop. You've probably messed it up. And I know that you've been reviewing all of the AI's work extremely carefully.
Well, I think that if it's code that's going to go into production that is supporting a paid product or service, you need to review the code, because you're accountable for the code. And there's going to be implications that the code is broken or insecure. So this is one. But if you're going to just do a little prototype or a fun weekend project, you can be a little laxer. So I think certainly in a professional setting, you need to review the code.
Yep. And we're trying to do things as much as we can across models, validating, reviewing, double checking things. Sometimes I'll have one model do the plan, one model do the validation, one model help me with the code. We are spending a lot of time thinking about how AI is going to become an effective team member for us, whether we're having them involved in reviewing pull requests, involved in writing tests. The thing that I think, if we call back to the beginning of the talk, that is the most exciting is this lower cost of exploring ideas. The distance between, I think I should make a Wordle thing, and shipping the Wordle thing is dramatically squished.
Yeah, and this slide highlights what the Aspire team does of working with the agents in the pull request system, where you can have it go work autonomously and then come back and review its work and tweak it. And if it's off the rails, you just cancel the PR, and there's no harm done to your code base. Otherwise, you just shape it into the point where you can accept it.
Indeed. And I think we call out that feedback loop, that developer's inner loop and that teammate's outer loop. If you've got good CI/CD, if you've got good tests, you're going to do better. But if you're just YOLOing and trying to vibe yourself into production, you're going to have a lot of challenges. Now, there are things that you don't think, Mark, are going to get fixed, that it's always going to behave a certain way, but we are seeing certain kinds of reliability that are continuing to improve.
Yeah, I mean, for sure, they're going to get better. They're more reliable, work on tasks more longer, keep more in the context about what they should be doing and not doing, security standards. There'll be more automation and deterministic verification that goes around it that will improve things. But they're never going to get to the point where you can just, as we call it, hand over the keys completely.
Exactly. So now that means that the bottleneck as software engineers is going to really shift towards us to have clear requirements, as much specificity about our specifications as possible, and CI and evaluation of the tests. The thing I thought was interesting is you called out token consumption is now going to become a bottleneck, the ability to get tokens in and out fast.
Yeah, well, actually, in this case, I talked about token consumptions as well, but in this case, I'm talking about if the cost of producing software goes close to zero, then the bottleneck is evaluating what comes out and also consuming it. If there's, it's like, so much code or so much of some product being created, how much does it want? It needs to evaluate it. It needs to actually consume it, deploy it, use it, start a feedback loop. It's going to be ultimately humans that are the bottlenecks because they're going to be the ones doing it.
That's a great point. Human consumption versus token consumption. Because if I write something in a couple of hours, but you can't even look at it, and the marketing team doesn't have a plan for a week or two, does it really matter that I got it out that fast? Yeah. So productivity then is going to scale based on our attention bandwidth. Yeah,
this is the one where if I can prompt all day long, I can have multiple projects going in flight. If I'm busy doing other things, or focusing on the evaluation part of something, then that's going to limit my bandwidth.
Yeah, the part that I'm loving about this is that the cost of trying things is dropping to zero. I'm doing experiments and silly bits of work and trying new things because it doesn't feel like it's wasting time. I'm learning so much and I'm getting so much done. I'm having so much fun, but I feel also that I'm sitting on 30 years plus of software engineering and an education that I think is going to be more important than ever.
Absolutely. You need to know complexity theory. You need to understand concurrency. You need to understand good architecture and design and, separation of concerns and security. All of that still matters.
So a quick advertisement at the end of our talk here. If you want to learn more about how Mark and I think about these things, whether it be vibe coding, AI-assisted coding, or just how people should interact with their computers, I would encourage you to check out our podcast, which is called Mark and Scott Learn To, where every week we try to learn something new, like this talk. Can AI take the wheel? I don't know, but we're going to continue to try to learn as much as we can every week on our show. So I would encourage folks at Snowflake to check that out. Big thanks to our friends at Snowflake. We hope that you have a wonderful conference, and thank you very much for having us.